Hello and welcome to this Aftermaths episode of the Primary Maths Podcast, the show where we talk all things primary maths. With me, John Cripwell.
And with me, Becky Brown.
Hello again, Becky. How are you this week?
Yeah, good, thank you. Enjoying the hot weather, although it's as we feel like we said this for weeks and weeks, haven't we? We thought it was a quick heatwave and gone. We're still talking about it.
I mean, it did get a little cooler, didn't it, for a few days? To be honest, it's lovely looking at it out the window. It looks gorgeous. Oh, I'm going to sound very middle-aged now. The garden's looking, the grass is looking a bit brown now, I have to say. But no, it's nice when you can enjoy it. Again, our heart goes out to anybody who is in a classroom with 30 overly hot and sticky children. But yeah, we're nearly there. We're nearly at the end of the year. So
close.
You know, good things are coming. Good things are coming. And I heard this morning about the possibility of a bank holiday if the impossible happens and I'll whisper it, England win the World Cup. That there may be an additional bank holiday. However, I think the date, because the final of the World Cup isn't for a couple of weeks, so I think the date of the bank holiday might be the first Monday of the summer holidays, which is typical for teachers, isn't it, and children, that it would fall at that time of year. I think there should be some sort of campaign. Maybe the unions could get on it to have a day in lieu, because teachers need to celebrate. Teachers need to celebrate big milestones like this as well, don't they?
Absolutely, yeah. I think we've got slightly split terms down here. So some schools finish on the Friday, but my children are definitely there till the Tuesday. So they would love that if there was a bank holiday on the Monday. But
well, that could work out in their favour yet. Then you never know. You never know. So we are going to talk about, actually, given that it is so hot and it's getting hotter. My question that I posed myself this week was, should we change the way that we teach? I mean, maths particularly, because this is the Primary Maths Podcast, but should we change the way that we teach during a heat wave? What do you reckon?
I think it will be impossible not to in the way that most schools, and I know some schools are lucky enough to have air conditioning, but the way that most schools are set up, I think you have to have some changes, not necessarily to maths, but generally in order to cope.
Yes.
I think.
I agree. But do you know what, Becky? I've got some science to back this up so that we can talk about exactly how and why that might happen. But yeah, I was thinking about this if I was teaching maths lessons this week. I mean, there's the obvious things, isn't there, we can try and engage the children with. We could suggest that all the problems should be based on word problems based on ice cream, maybe. And you could do that practically and get some tubs of ice cream in, having checked all the allergies first, of course, and the dairy intolerances, etc. You could have practical problems about going to an ice cream parlour, maybe, or I like this one, although it's a very simple ratio, the ratio of vanilla to strawberry to chocolate in a Neapolitan ice cream. What's the ideal? What's the ideal ratio there? Is it 1 to 1 to 1, or would you have more of one than the other?
I would get rid of the chocolate entirely and just have...
Would you? Yeah. Oh, that's controversial.
Yeah, I know.
That is a big call.
I'd double up the strawberry, I think.
We've just lost. Do you know how many listeners we've just lost there, Becky?
Sorry.
I'm just turned off in disgust. No chocolate ice cream in a Neapolitan.
No. I love chocolate. I just don't like chocolate ice cream. I don't know. No.
I don't think you see Neapolitan ice cream as much anymore. Or maybe it's just in my freezer it hasn't appeared for a little while. But as a kid, I used to like getting it and mixing it all up.
I think the thing is now there are so many flavours of ice cream available, aren't there? You just go to, if you go to a kiosk somewhere, I mean, birthday cake ice cream, salted caramel, which didn't exist 5 years ago.
I was very lucky yesterday. I went to pick up my daughter from school and I ended up getting there about 20 minutes too early, and it was too hot to stand in the car park waiting for her or anything. But just down the road from her school is a park, and in the park is a little business called Just Ice, and you'll see what they've done there in a moment. It's actually a little charity ice cream parlour where they make all the ice cream on site, and they some of the profits go towards trying to eradicate modern slavery. So I was doing my good deed for the day when I went along to that ice cream parlour and and went for a mint choc chip because it felt like the most refreshing option on a very hot day. But they had some wonderful flavours there. Yeah, some really nice ones. So if you happen to be in Derby, somewhere near Dolly Abbey Park, then pop down to this is not a product placement. They're not paying us for this, but I would highly recommend their choice of flavours and very nice service as well. You can have a little chat with the lady in the kiosk. Anyway, I've gone miles off what we were talking about there, which was ratios of Neapolitan ice creams. I also thought maybe you could bring in a little water pistol, and I thought initially incorrect answers they could get squirted, but then everybody would be trying to give you an incorrect answer, wouldn't they? So maybe just go for a right answer. Gets rewarded with being squirted with the water pistol. Yeah, I quite like that. But it is a fact that it is harder to keep people, children, engaged. And I had a little look into why this might be. So what happens to us when we're working in extreme heat? Okay. I know some places in the world wouldn't call this extreme, but I think for us, over 30 degrees is fairly extreme. And there's quite a lot of evidence, actually, that suggests that it directly affects cognitive capacity and ability to cope with additional cognitive load. So there was a study in 2022 of miners. Why miners? I don't know. I know they have to work in extreme heat sometimes, I suppose, but they weren't doing mining as part of this study. Instead, what they got these participants to do, it was a fairly small group, to be honest, but it was still interesting. They got them to complete some cognitive tasks after they had walked on a treadmill, which is, obviously part of what you do as a miner. First in a temperature-controlled 21 degrees, and then in a temperature-controlled 37 degrees.
Wow.
Yeah, which is warm, isn't it? Although you were saying the thermometer at your desk was 35 degrees
35,
last week. So no surprises really that the heat affected things such as reaction times, accuracy, and this was the bit that was interesting for me, verbal memory. So being able to talk about something that had happened recently. And I was thinking for maths in particular, but also for English and lots of other subjects, we talk about the importance of oracy and being able to articulate and verbalize what we're talking about. And there's direct evidence that extreme heat affects our ability to do that, which is interesting. And then there was another study that I found, this time of students in Boston, and this was during a heat wave. So I don't know whether they planned this or they just, there was a heat wave and they thought, we'll see what was happening. Yeah. But they had two buildings, one with air conditioning and one without air conditioning. And they had the students in one of the buildings first and one of them afterwards, and they compared how they worked in those two buildings. And this time they found reductions in working memory and selective attention and processing speed. Again, all things that you would think in a maths lesson particularly are really important. That working memory is really important, isn't it? Because we're working on, prior learning and making connections and trying to hold pieces of information while we add other pieces of information in to solve problems and things. And obviously processing speed as well. Huge. So it's science, is what I'm saying, Becky. It's science. You can all go to your head teachers and things and say that you can't teach maths effectively until either they give you air conditioning or this heat wave dissipates. And I was thinking about a line from John Sweller, which was talking about learning being hindered when working memory is overloaded, and that's what's happening at the moment, isn't it? Everybody's working memory is just kind of overloaded because it just doesn't have the capacity that that it ordinarily would have. So it's not just because people are complaining because it's hot. It genuinely affects our ability to learn and to work and to function effectively.
Yeah, but that's really interesting, John. I mean, anecdotally, of course, you do know that it makes you feel a bit of brain fog comes down, if you like. You do start to feel a little bit, not that you can't concentrate as much, but it's really interesting to have it backed by science. And I guess also coupled with the idea that maybe you might not be sleeping as well.
Yeah.
Is another thing that will affect
Yeah, we know how important sleep is, don't we, for working memory and long-term memory and things like that as well, and being attentive during the day.
So this could actually have quite a big impact, couldn't it?
Well, coupled with a World Cup going on as well, where people are losing sleep because and I'm not just talking about pupils here.
4:00 in the morning. Yeah. Just thinking of some schools in some areas will be lucky enough to have air conditioning. Some homes will be lucky enough to have air conditioning, but that might create a bit of a disparity, mightn't it, between different areas and different.
Well, even within a school. So the last school that I worked at, I think out of 14 or 15 classrooms, 3 of them had air conditioning. And you can imagine where we used to have staff meetings.
Yeah.
But if you were lucky enough to have one of those classrooms, you were, the office had air conditioning actually as well, which was a slight bone of contention. Although I didn't resent them for that. I just used to go and hang out in there and have my lunch. But the first class I ever worked in had air conditioning.
Wow.
But we weren't allowed to use it. So it was just up there on the wall and everybody could see it. The children could see it. I could see it. But the remote had been taken away and locked away somewhere so that it couldn't be used on cost effectiveness grounds, I think, which is and this is going back a long time before budgets are quite what they are today. So yeah. So I suppose, what does that mean then if you are teaching maths at the moment? What do you do? You can do the ice cream problems and things like that. But the things that I was really thinking about were just making sure, I suppose, having an awareness of it, which we all do. Again, it's common sense, isn't it? But shorter bursts, perhaps.
Yeah.
More opportunities for talk, because we know that it affects verbal memory, so therefore we need to do a bit more of that, perhaps. Less teacher talk, less us standing there talking, which we don't want to do anyway, do we? And probably the biggest thing, fewer instructions, probably, because we know that working memory is not going to be as effective. So keep it simple, break it down, do half the lesson over the same amount of time, maybe. And if you happen to be a leader in school, aware of this, I know you will be aware of this, but just bear that in mind, perhaps.
Yeah.
And it's a funny time of year anyway, isn't it? But I know lots of teachers are trying to plug gaps and things so that the children are ready to move up to their next class and their next year group and their next challenge. And it's tricky at the moment.
Yeah. I think, and teachers already have a really good understanding of working memory and what we should be doing. So I guess it's just overdoing it a little bit, maybe. And like you say, breaking it down. Hydration breaks.
Hydration breaks. That's where we're at. Yes. Yeah. Yeah. And you can put some adverts on at the same time. Yeah.
Yes.
Yeah. Hydration breaks. That's the new thing. But no, in all seriousness, it makes sense, doesn't it? Make sure that children have got access to water and things, and give them a break, give them more breaks. And as I say, you can say that that's backed by science. My thermometer at my desk at the moment is reading 32.6 degrees. So toasty. Yeah, toasty in here. Right, Becky, we're all friends here.
Oh, no.
Okay? No judgment. No judgment from me. No judgment from the listeners. Everybody knows you, loves you. It's all fine. Okay? But if I said to you, what's 17 multiplied by 10? What do you do in your head to work that out?
I see it, actually. I visualize it. And I don't
Okay.
know. I don't know if I would be doing it that way if I didn't know that this can be.
If it hadn't been drummed into you.
Yeah, but I think I visualize lots of things in maths, but I think I see it I see the number. I don't necessarily see it moving, which I know is maybe one way of teaching it, but I see it and I see 170.
Okay, well, what happens? So you see 17,
Yeah.
and then we're multiplying by 10. So what happens in your head, in your visualization? To be honest,
So they shift along.
they shift along, do they?
But the 17 stays there, and then the
So it doesn't shift along.
No, actually, the 170 appears underneath, like if you were writing on a calculator.
Okay, or if you were writing it on a place value chart and you start with the 17 and then you...
Yeah, and as I
So
said...
does the 7 go into the tens column then? Does the 7 appear below the 1 in your visualization?
Yes.
Well, you are just...
I think that's because I've had it drilled in. I think that's because I know what you're going to talk about now. And I've taught myself to think about it.
I came across an interesting article as I was browsing this week about whether it's ever okay to say that if you multiply by 10, you just put a 0 on the end. Now, obviously, we know the potential pitfalls with that, don't we?
I think it all comes down to language, actually. I think saying add a 0, which is what lots of children will say, has its own complications because you're not adding 0, and you know...
Yeah, you're not adding anything. It's a multiplicative structure, isn't it?
Yeah.
I think... So we've all had those children in class, probably not in year 1 or reception. We're not really doing that. We might be counting in multiples of 10, I guess, in year 1. But as we go through school, we probably come across those typically high-attaining pupils who, if you said 17 times 10, they'd say 170. If you said, how do you know that? They'd say, well, yeah, I added a 0 on the end. To me, that's slightly different from a child who is coming across this for the first time and they say, I'm adding a 0 on the end.
Yeah.
Because one, I think, is a misuse of language, and I agree we should pick that up and correct it because it's important to be accurate, isn't it, with our language and precise. That's part of being a good mathematician, I think. But with that first child that we were talking about, the one who can see it and knows it and has misspoken, perhaps, knowing the child, you probably think actually they really understand the structure.
Yeah. It all comes down to that understanding about place value again, doesn't it? And whether there is one.
Yes. Yeah. So I was thinking ahead to September because I know that everybody's going to be working on place value again in September, and probably not starting with this, to be honest. But I was thinking about that, and then I started thinking about generally more maths hacks. So we see these maths hacks around, don't we? Shortcuts to do things. Divisibility rules might be some of them, or quite a few viral videos online that show different ways of doing things that maybe aren't the way that we would necessarily teach them to understand the structure. And I was thinking, are those things ever okay?
That's a hard one. It's difficult, isn't it? Because I think sometimes things as memory joggers can be really helpful. I'm thinking past primary, but SOHCAHTOA, and thinking about trigonometry. And it's not really a hack, but having those things as memory joggers are really important. But I do think that having an understanding is really important. We know that if you just say that you're putting a 0 on the end, when you come to deal with decimals and you start doing that. However, that's a great conversation, isn't it? That's actually a great lesson to have around why that is the case. So I think it's just important to teach that conceptual understanding. I don't know. How do you feel about these hacks, Jon?
For me, they have a place, but they're never the starting point.
Mm-hmm.
So if we think about fluency, then you could argue that they might have a place within fluency as a shortcut to doing something. But understanding why they work is really important. And I don't think you can understand why it works if you don't have a solid understanding of the concept behind it.
Yeah.
So with one that we're all familiar with, placing a 0 on the end, the way that that's working clearly is that it is changing the place value of the other digits in the number. So 17, as we were just saying, the 7 becomes a 70. It moves into the tens column, 10 lots of 7. And so I know that that's why that works. So if I'm doing 17 times 10, at no point in my head am I thinking, okay, well, I'm going to shift everything along one place on my place value chart internally, and therefore it's going to the 1 is the 10 the 1 in the tens column is going to become a 1 in the hundreds column, and like that's not how it works, is it? I just, like one of those annoying children in class, I just know that it works, that becomes that. And if I say I've added a 0 on the end, I know that I haven't really added a 0. I've just misspoken and used incorrect language, which again, I think it's fine to pick up on, and should be challenged, because not just for that child, but for anybody else who's heard that in class, it needs addressing, doesn't it? Because that's where sometimes these misconceptions can come from. One child's heard another child say it, makes perfect sense to the first child who said it. The second child misunderstands, and thinks that it will always work. And that's the other thing. Do these hacks always work, or are they just in specific circumstances that they work? Because we know conceptual understanding always works, because we really understand the structure of what's happening. But a maths hack might only work in limited circumstances, and it's important to understand the extent of that as well, isn't it?
Yeah. Again, it comes down to, you would do that, but we know that you have a good conceptual understanding of place value. I hope so, Jon.
It's reasonable, Becky. Yeah, it's reasonable.
And it comes down to, again, knowing what your children's understanding is. And the best way to know that is through talk, isn't it? And discussion, not necessarily through doing calculations. But
so Bruner obviously famously said that understanding depends on seeing structure. Essentially, I'm paraphrasing. But the structure was the important bit. And if you don't see the structure, you can't truly understand it. And I would argue then that these things just become a procedure then, whether they're a hack or just a formal written method even, they simply become a procedure, and you lose that understanding because you don't have the structure. But I think when you've got that understanding, then you can look for easier ways of doing the maths. Again, we go back to this idea that I don't want children to be doing 1,000 or 1,001 take away 999 using a formal written method. That might be a way that it's been taught, but I want them to see the structure and see actually that there's just a difference of 2. And so using the right tool at the right time is important, isn't it? But again, that only comes with the understanding of the structure. Let me go off on a slight tangent here. Okay. So I think that this really comes down to when you are proficient enough that you really understand something, then you can start to find the shortcuts or the better ways of doing it. And I'll give you a non-maths example, okay? Do you remember the 1968 Summer Olympics, Becky?
how rude. No, I don't, Jon.
No, you were away that summer. So something, clearly, neither of us are old enough for that, Becky. Something fundamentally changed athletics in 1968. I wonder if any of the listeners are ahead of me here. But an American guy called Dick Fosbury revolutionized high jump, because he for the first time at the 1968 Olympics introduced the Fosbury Flop, which is easy for me to say. But that's the way that everybody does high jump now. Up until that point, though, nobody did it that way. They did like a scissors over the top of it and things. But he realised that actually the high jump wasn't about who can jump the highest.
Mm-hmm.
It was about just getting over the bar. And it didn't matter how high your head was off the floor. It was really about understanding what you were really trying to do. And so because he'd seen that, he was able to find a different way through it. And it changed everything. Now, I'm not suggesting that just saying put a 0 on the end is the mathematical equivalent of revolutionizing modern athletics. But the point was that he was proficient enough that he could get away with doing that without breaking any of the rules, without disqualifying himself, without getting it wrong. Although lots of people thought at the time that maybe he was. It was all perfectly legal and a perfectly valid way of doing it. He was just seeing something in a different way. And sometimes I think in maths, we can run the risk of being very reluctant to let children see things in a different way, and maybe hamstring them a little bit unintentionally, because we want them to learn the procedures and we want them to be able to answer the question. I think we need to be careful that we don't let them explore, we don't let them see things their way, because we want to funnel them down a very specific route, if that makes sense.
Yeah, it's that balance again, isn't it, between discovery and direct instruction, and what that discovery looks like as well. It's a tricky one, but and actually for some children, discovering what happens when you make a number 10 times bigger will be much more powerful.
And also, what happens when you put a 0 on the end of a decimal number?
Yeah, exactly. There's some really good learning there, isn't there? That doesn't necessarily need explicit, children could
if you were to say, Becky, in class, a child says, I've just put a 0 on the end, and you went, no, that's wrong. Everything moves on the place value. You've lost something, haven't you? You've lost that opportunity, A, to challenge what they really understand and get to know what they really understand, but B, also to expose a misconception about it.
Yeah, definitely.
And if you can say, well, what happens if it's 17.5? And they can explain to you, well, actually, in that case, it wouldn't work because we're not changing anything. Then that tells you something, doesn't it, about that child's understanding of the structure of multiplicative relationships and place value.
It's that time, isn't it? Having that time to discuss. So valuable.
It is. But the thing I always come back to with that is, yes, I know it's difficult. It feels like we don't have the time, but actually what you're losing by not taking that minute, I think is worth much more than a minute in terms of that progress. Just my own thoughts there. But yeah, I just think it's interesting. This year marks 50 years, Becky, since Richard Skemp wrote Relational Understanding. And it feels like we're still trying to get towards that, trying to ease that tension between, are we just trying to get the answer, or are we actually trying to understand what happens in maths?
That is a journey, isn't it?
Yeah, it's definitely ongoing. And as we've said before, I think the way that teachers are judged and the way children are assessed and things all have a part to play in that. Because if we're still timing children how quickly they can get the right answers, yes, that's helped if they've got conceptual understanding massively.
Okay.
But it doesn't make it feel like that's actually what we're striving towards, as it makes it feel like actually what we're trying to do is get them to get the right answers as quickly as possible.
Yeah.
And that doesn't sit particularly well with me.
No, me neither.
Incidentally, as we are recording this, we know that you'll be, if you're listening to this as a teacher or an educator, you'll be thinking about place value for September. Our brand new PlanIt Maths Place Value resources are now available and on the Twinkl website. And if you have a subscription, you should be able to go and download those and have a look at them. They've all been completely rewritten, completely updated based on the latest pedagogy and representations and things. And I think they are a wonderful resource. So go and have a look and check those out. Whether you want to use them as a scheme or supplemental to whatever else you're doing in school, I think they're genuinely a fantastic resource, Becky.
Yeah, absolutely. So much work has gone into them, as you said, completely new. They're looking great. So yeah, if you're starting to think about September, perfect time to go and check them out.
Yeah. In fact, the whole scheme will be up and available on certainly the whole of autumn and spring, I think, will be available for the start of September. But you can go and have a look at those resources now. I think that's all we have time for. As ever, if you would like us to discuss any of your questions or just get in touch, you can email us at primarymathspodcast@twinkl.co.uk.
Yeah, thank you for joining us, and we'll see you next time.
Thanks a lot. Take care.